Welcome to our presentation on the Food Drive Optimization Project, a collaborative effort by the NorQuest College team to revolutionize how food drives are managed and executed. I'm Uche Nambwaja, the course instructor and project coordinator for this project, and I am joined by my esteemed colleagues as well as our dedicated students. We're here to share insights into the Food Drive Optimization Project. This project embodies NorQuest College's commitment to innovative learning and community service.
My name is Stephanie Husby, and I'm the Program Chair for the Machine Learning Analyst Diploma Program at NorQuest College. With a strong background in technology and education, my focus is on guiding our programs to not only meet the high standards of academic excellence, but also to ensure they remain relevant and responsive to the ever-changing demands of the tech industry. In my role, I oversee the curriculum development, ensuring it integrates the latest advancements in AI and machine learning, and I work closely with industry partners to align our educational offerings with real-world needs. This commitment to excellence and relevance is evident in projects like the Food Drive Optimization Project, where our students apply their learning to make a tangible impact on the community.
My name is Kaylee Kreller, and I am the Community Service Learning Representative at NorQuest College, one of 4. My role is to weave work-integrated learning or WIL opportunities into the fabric of our educational programs, ensuring that our students not only gain theoretical knowledge, but also are able to apply it in real-world settings. At NorQuest, we are committed to preparing our students for the dynamic challenges they face in the workforce through experiential learning opportunities that foster social justice, cultural awareness, and community engagement.
I'm Nazmus Sakif. I'm a machine learning instructor at NorQuest College. So for this particular project, my primary role involved providing hands-on support to our instructor Uchena, ensuring that our students not only understand the theoretical aspects of machine learning, but also gain practical skills through rigorous lab sessions. My focus is on creating an engaging, supportive environment where students can really experiment, troubleshoot, and ultimately thrive in applying their knowledge to real-world challenges. I played a pivotal role in guiding students through the process of data analysis and developing machine learning models. I'm passionate about empowering students to leverage their technical skills for social good, and it has been incredibly rewarding to see that our students applying their learning to make a significant impact through the Food Drive Optimization Project.
Hey, I'm Sajdeep Ojla. I had the crucial role of coordinating logistics to ensure our students could actively participate in the community's efforts at various donation centers. My responsibility was not only to facilitate smooth transportation, but also guarantee that each student received the support and guidance necessary to contribute meaningfully to the project. My dedication to overcome operational hurdles and nurturing a supportive, safe environment allowed our students to immerse themselves fully in the vital community services, enhancing their educational experience with real-world application. I'm proud to have been a part of this project, helping to bridge a gap between our students and the community needs. Thank you.
I'm Divya, and this is my final semester in the Machine Learning Diploma program at NorQuest. This was my first time working on a real-time project. This journey of utilizing classroom learnings to benefit the society was remarkable. Working for a project that feeds the hunger of the city also gave us an added responsibility. From collecting the data in the field to deploying the final app, this project has helped me develop a lot of transferable skills that would benefit me in my professional life. I am very grateful for the wonderful opportunity provided by the stakeholders. I also thank our instructors for their continued support in this project.
Hello, I'm Vanshika, currently in my 4th semester of the Machine Learning Analyst Program Diploma. I'd like to share my experience with the Food Drive project. It was incredibly insightful to work on the project, as it provided a comprehensive understanding of the entire process, starting from data collection, data cleaning, exploratory data analysis, outlier handling, feature engineering to model building. I'm grateful to NorQuest College for incorporating this project into our curriculum.
Hello, I'm Greta Pedro, a machine learning analyst student involved in our food drive optimization project. Leveraging my academic research background, I specialize in uncovering actionable insights to optimize processes. Through advanced modeling techniques, we've been able to streamline operations and enhance efficiency, ensuring our food drive efforts make a significant impact. I'm thankful for the opportunity to contribute to such a meaningful cause and make a positive impact into our community.
Hi, I'm Aleli Renee Ilagan, a fourth-term machine learning analyst student. I'm driven by the potential of artificial intelligence to drive positive change. I have a background in business administration and a passion for data-driven solutions. It's been an honor being part of the Food Drive Optimization project, where we used machine learning to improve donation collection and distribution, proudly minimizing waste to maximize impact and hopefully reach more people. I'm dedicated to use technology to benefit businesses and communities. I'm excited to share insights and continue this journey with fellow changemakers. Thank you.
Hi, I'm Jivesh, currently pursuing my machine learning diploma, and right now I'm in the last semester of my studies. In the previous semester, I had this opportunity to work on the Edmonton Food Day project along with my peers. It was a great experience to be part of this project. It gave me an opportunity to leverage my classroom knowledge and to solve a real-world problem. There were different stages of this project, and each stage took us several months to complete. And this taught me how real-world projects work actually. Not just the technical part, I was able to get involved in the field and give a hand in the donation collection process itself. Through all this effort, I was able to polish my analytical and problem-solving skills, which will be a huge asset for me in my professional life. In the end, I am thankful for this great opportunity to contribute to such a noble cause and make a positive impact in the society. Thank you.
So the Food Drive project really began when we were approached by one of our partners at the City of Edmonton. And our City of Edmonton partner came to us because the Latter-day Saints Church had reached out to them with this problem around the food drive. So the food drive is one of the biggest food collection days for the Edmonton Food Bank, and they collect over 300,000 pounds of food during that time. It's a really impactful event. And the group had been using some old maps, some newspaper routes and things like that in order to deploy their volunteers. They were looking to modernize and digitize some of those things. And so we got this opportunity that we were thankful to connect with the Latter-day Saints Church and the food drive organizers. Our students were able to go out and collect data firsthand, and we can really leverage our expertise to support this really important initiative in our community. And so our job in this program really is to make those industry connections and to give students these types of real-world work experience. And we're really thankful for this opportunity with them.
Hello everyone, I am excited to introduce our innovative project, the Edmonton Food Drive Optimization. Our team developed this project as a part of our community service learning under the machine learning program at NorQuest College. We've collaborated with the City of Edmonton, Just Serve, the Edmonton Food Bank, and the Church of Jesus Christ Latter-day Saints. After several meetings with the stakeholders, we've discovered that the food donation system in Edmonton was facing logistical problems that were impacting its overall efficiency. To address this issue, we've utilized machine learning to develop a user-friendly mobile app that optimizes resource allocation, streamlines the donation collection, and serves as a tool for collecting better data to aid future evaluation and decision-making by the organizers. The goals and objectives of these projects are the following. For resource allocation, to ensure the success of a food drive, it's a must to efficiently allocate resources such as bags, volunteers, and organizers to match the needs of each donation site. Our machine learning models analyze data to optimize this process, minimizing waste and maximizing the food drive's impact. Second, we have centralized system. Previously, there was no uniform method for collecting data related to the food drive. With that in mind, we set out to create a centralized platform that can streamline the various aspects, ranging from volunteer coordination to donation tracking. Moreover, the data collection will assist in the decision makers identifying and targeting areas that generate more donations. Lastly, we have route optimization. We'll apply an algorithm to generate the most efficient collection route, minimizing the volunteers' travel time and the distance between collection points. This will allow volunteers to cover more houses in less time, saving resources such as bags and fuel. And it will also ensure that the donated food items are collected promptly and that there are no routes left uncollected. So for our project timeline, we have data collection and preparation. We've been hands-on in the food drive, from giving out bags to counting them on the collection day. This gave us important insights and domain knowledge for collecting and preparing the data effectively. This is a crucial step before we can use machine learning because it involves cleaning and processing the data, making it easier for the model to understand and learn from it. Second, we have the model development and training. Machine learning helps us make sense of the data we've collected. It helps in making better decisions and improving the food drive's overall operations. In our case, we've used multiple models to analyze our data, and we've selected the most accurate one to integrate into our app. Third, we have the app creation and integration. We've created a simple mobile app linked with Google Forms and set it up on Streamlit. Why mobile? Because most people have smartphones, which allow them to participate from anywhere. Additionally, mobile apps offer features such as GPS, which is useful for our route optimization. Lastly, we have our deployment and handover. We are very proud that our app is ready to use. Just scan the QR code and voila, you're ready to go. We'll also gather feedback to improve the app and ensure we continuously meet the stakeholders' needs. In the next parts of this presentation, my colleagues will dive deeper into each step.
I will be presenting EDA summary. So EDA stands for Exploratory Data Analysis. It's a process used to understand the main characteristics of a dataset. It's essential for uncovering patterns, relationships, anomalies, and other insights within the data. It involves techniques such as summarizing the main features, visualizing it using graphs or charts, and identifying any interesting patterns or trends. EDA helps us gain a deeper understanding of the data before diving into more advanced analysis or modeling. And before we proceed, please note that the terms ward and route will be used interchangeably. So an outlier is a data point that significantly deviates from the rest of the dataset. We detected outliers and addressed them by considering the context of the entire data. So for instance, one outlier here showed a donation bag collection of 550, which initially seemed plausible. However, upon closer examination, we discovered that this value was the result of two people collecting bags in less than an hour. By contextualizing this specific data point, we deduced that the most likely scenario was a collection of 55 bags, providing a more accurate representation of the situation. Correlations play a vital role in guiding our strategy for imputing or filling in missing values. By understanding the relationships between different columns, we gain valuable insights that help us accurately fill in the gaps in our data. For instance, we observe positive correlations between these variables, suggesting that as the number of doors increases, so do the other values. Therefore, we can confidently use linear interpolation based on the route doors column as the most suitable method for filling in missing values, as it aligns with the patterns we observe. This graph here shows us the proportion of bags collected to the total number of houses for each ward. This trend in the blue dotted line illustrates that the relationship between the total number of houses and the total number of donation bags is not completely linear if we take the wards into account. And the star here points towards that despite having a lower number of households, they contribute a disproportionately high number of donation bags. This underscores the importance of targeting these neighborhoods in our donation efforts and prioritize high yield routes. For key insights, around 30 bags were collected per route, and on average, it took about an hour to complete a route, and about 29% of households along a route made donations. There were 9 drop-off locations, and Gateway Center was the most frequently used. Over 15,000 donation bags were collected in total, and 703 routes were completed. Although 1,700 volunteers were recorded, this number doesn't accurately represent the total volunteers, as some individuals completed multiple routes and submitted the form multiple times. In conclusion, our exploratory data analysis has offered valuable insights for enhancing research management and donation initiatives. The significance of this process cannot be overstated. Estimating values and filling in missing data with interpolated values underscore the critical need for accurate data collection, particularly concerning ward or route-specific information. This is crucial for future planning and resource allocation.
Let's understand the machine learning part. Unlike traditional programming, where developers write explicit instructions for the computer to follow, machine learning focuses on developing algorithms and models that allow computers to learn from and make predictions or decisions based on the data. In this project, we have worked on 2 different machine learning problems: a classification problem that classifies if a given route takes more than an hour or not, a regression model that predicts the number of donation bags per route. In both the cases, we have analyzed 3 different models: KNN, which is a simple and easy to implement algorithm; decision tree that handles various data types and are interpretable; random forest improves the accuracy by combining multiple decision trees. In the case of classification, random forest classifier was chosen as it had the highest accuracy. On the other hand, for the regression problem, a model with low mean square error and high R2 score is recommended. In this case, it was random forest regressor. One of the additional features provided in the app was an interactive map that was powered by Google My Maps. The City of Edmonton property assessment dataset was merged with our data to obtain the longitude and latitude information. Another interesting part was integrating a chatbot assistant. This was achieved by using gradient-based model, specifically the Noz-Hermes 2 base model. This created a user-friendly interface for the users to get answers for their questions about food drive in real time.
Hello, my name is Keaton Schubert. I'll be doing the application demo for the Edmonton City Food Drive project. This app is publicly accessible. It's hosted on Streamlit as a web application. And really what this app does is just put our work somewhere where users can view it, interact with the models, see our data analysis, and also see some of the insights we gathered during this project. Starting with a quick dashboard talking about what the project is and why we did it. Moving on to the data analysis with a quick disclaimer, all this data is only collected. All the data used is from the collaboration between NorQuest and the Edmonton Food Drive. There's no previous years or additional data sources used. So we start with our key analysis, the key features we looked at, which was time to complete the routes, the average bags collected per route in each stake, which are the larger areas that contain the wards and branches, the total bags collected in each stake, and farther down we have ward information that is filterable by one or many or no stakes, and this is to provide users a filtered view of the data that's important to them instead of having to skim through all of the data. Then we have our first of 2 models, which is our time prediction. Now this model only uses data volunteers would have access to before completing their routes. So by predicting how long a route would take, this would give the volunteers an opportunity to accept or decline depending on if they had that amount of time available. Our second model is our bag prediction, and this is used more to validate how many bags we would get from this other information, including the number of routes and the time spent. Then we have our stake and ward map, and this contains additional data from one of the drop-off locations, the Londonderry Chapel. And they had put their route information into Google My Maps. And what we did is we combined this route information with an open City of Edmonton data set about property. So what we took from there is the number of houses and then also the average value of those houses. And this is mainly to highlight what we can do with this route information. And this would allow us to compare routes to one another with different factors other than those that are collected during the food drive. We also have an integrated chatbot that'll answer food drive questions and can sometimes provide specific information about this project. We also have our updated data collection form. It's very streamlined and it contains the route number, as we've identified this as a crucial feature to collect to get better insights and more specific insights about the food drive, which will allow us to better optimize the process.
Moving on to the next slide, we have business values and impact. The completion of food drive project led to efficient resource allocation, that is, it would impact 15 to 20% reduction in waste and will help saving the cost and would lead efficient inventory management. It will help in optimizing volunteer support based on the data provided. It can improve volunteer satisfaction up to 20%. Moreover, it will help in making informed decisions. This project will lead to more accurate decisions, resulting in more effective operations and strategies. Apart from that, it would help in time management, as the route which has more doors, more volunteers can be appointed for that particular route. Talking about MLA tool stack, every project needs communication with team members, and for that we used Microsoft Team Notion. Obviously, for developing the backend of the app, we used Jupyter Notebooks and Python programming language. And we used different libraries of Python such as Pandas, scikit-learn, matplotlib, and plotly. For managing the different routes, we use Google Maps, and we used Google Forms while collecting the data for the food drive. For version control and collaboration, we used GitHub and NorQuest repo. We used Streamlit for deployment of the app. Responsible AI. While doing the project, we have keep in mind the privacy. We make sure that recipient and donor information is kept safe with strong security measures. Reliability. The data we have is trustworthy because it comes directly from volunteers who filled out a Google form. We didn't add any fake information. Transparency. To keep things private, we kept project details within our team until we had a strong privacy measures in place. Removing personal data of volunteers follow ethical rules and laws. In summary, we have collected the data through Google Forms, and for the machine learning model, we choose random forest. Through random forest, we have solved two problems. One for regression to predict the number of donation bags, and one for classification to predict the route based on the time taken. Lastly, we developed an app with interactive map and chat box assistance, and hence accomplish our aim to optimize resource allocation for Edmonton food drive. In conclusion, Our project used information we gathered to better organize important things like volunteers, time, money, and effort for the food drive. We handled complicated data and made sure we were using artificial intelligence responsibly. As a result, we found useful ideas to make our service delivery more efficient and effective. In the end, I would like to thank NorQuest College, the Church of Jesus Christ, the City of Edmonton, Just Serve, and Edmonton Food Bank for giving us this great opportunity to do this project. Thank you.
Hey Jivesh, how was your experience with the food drive project? It was a great experience for me. It gave me an exposure to use my classroom knowledge and to transfer it to solve a real world problem, which was a great opportunity. How was your experience?
For me, the best part was the data collection. So the first time when we engaged as a volunteers in the food drive process, we went in person during the process. We helped the volunteers with the data collection part. We not only helped them with the data collection part, we were in the part of the food drive, like in the collection of food donation bags. And while in this whole process, we also encountered with a lot of logistical challenges they faced during the process. Like for example, the map integration part, like which was not even the part of the plan when the project started, but during the process we encountered with that issue. So to solve that issue, we uh, integrated a map in our app. So these were all the challenges we faced during the project. What were the challenges you faced during the project?
For me, the biggest challenge with was the data. The data we collected only represented a small portion of the city and not all the regions were included in it. And moreover, the data had a lot of inconsistency in it. There were missing values, there were duplicate rows, and also there were outliers. To tackle these problems, we had to deploy our machine learning techniques and also the EDA techniques we have learned in the class, which gave us an opportunity to solve the problem.
As the challenges bring the opportunities to learn. So what were the values you gained from this project?
No doubt the cleaning part and the other EDA parts were hard but tough, but I could learn a lot of skills from this as well. I developed problem solving skills, and it also incorporated in me the habit of giving attention to details. Which are these are some of the transferable skills which I can use in my professional life when I start my career in this field. So this was a very valuable project. In a nutshell, I would like to say that it was a win-win situation for both the stakeholders and the students involved, as we were able to solve the problem they were facing, and we could learn valuable skills from this project, which we can use in our life.
The course is designed to foster ongoing engagement with stakeholders, ensuring that the machine learning solutions our students develop meet the client's specifications. The collaborative process begins with a project kickoff meeting with clients, followed by 3 scheduled demonstrations. The first demonstration focuses on exploratory data analysis, also called EDA, where students share their techniques for data collection, data cleaning, processing, and the insights that they've gathered. The subsequent demos, the model iteration, involves the development and evaluation of various machine learning models against predefined metrics. The culmination of this process is a deployment demo where a functional prototype of the application is presented to stakeholders for testing and feedback. This provides a tangible example of the project's progress and potential impact.
I'm a firm believer in the power of work-integrated learning as a tool for empowering students. It bridges the gap between theoretical knowledge and practical application, providing students with invaluable experience and insights into their future careers. The success of our students in projects such as the Food Drive Optimization Project underlines the importance of hands-on experiential learning, and it's something I'm deeply passionate about. At NorQuest College, we're dedicated to preparing our students not just for their first job, but for a lifelong career in a rapidly evolving field. It's my privilege to be part of their educational journey, supporting them as they grow into skilled professionals, ready to tackle the challenges of tomorrow.